I want B bar inside the solenoid. Where the field is uniform, there I want the B bar. And so what is the field strength? Field strength will be come for this. So there's a B bar. Let what is small n? Number of turns per unit length. What should be the plane curve? What type of plane curve I should assume now? I'm going to assume a plane curve dotted. Now, if you want, you can make it solid. There's a plane curve I'm assuming. So this you call loop. What is the man field outside the solenoid? I say 0. Is it really 0? Is it really 0? So you go back to solenoid. So this was the I'm going to claim that the field will be 0, but lines of force will be there, but field will be 0. So it will go to. I'm showing few lines of force. This should be actually the field inside the. Look at these arrows. So here current will be the out of the plane. Yeah, this will be the direction of field. Arrows. Solenoid, according to the solenoid. I'll change this one. Come for this one. Yeah. This will be the direction of lines of force. No, what are any lines of force will be there? Yes. So what is the usually radius of the solenoid? The diameter of solenoid. Let me take. It'll be 10 centimeter or at the most 2, 3, 4, 10 centimeter. And what about till infinity? In 10 centimeter, in the 10 centimeter distance d, let there be some select 20 lines. Then from here to infinity, around so 20 lines are there, means 10 lines will pass here, 10 lines will pass here. So from here to from this side of the solenoid to infinity, what pen there'll be 10 lines, and from here this side of the solenoid to the infinity 10 lines. In the width d, I'm assuming 20 lines. So here till infinity 10 lines means what pen? Almost the field is negligible, no? So therefore, what will be the field inside the solenoid? Will be non-zero. The field here non-zero. What about field here? Non-zero. What about field on the axis? Non-zero. What about field at this point? You must say 0 only. B1 non-zero, B2 non-zero, B3 non-zero, B4 0, B5 0. Though I'm showing some few field lines of force, but see till infinity means I think it's understood, no? The field is negligible, practically we'll make it 0. So therefore, if you keep bar magnet here, compass needle here, will it deflect? No. If compass needle kept here, it will deflect on the axis. So till where axis? It will to some distance here. Afterwards, some say like a suppose a length of the solenoid is 10 centimeter. As you move from this end, say like a 2, 3, 4, 5, 6, 7, 8, 9, the field will become almost the 4 times of the solenoid. No, the field will become negligible here. So even at 3, better to say non-zero only. Don't say 0. Somewhere far away, it will be 0 here. So what about field? Field here should be 0. It should be 0 because this length is infinite. No, from here to infinity, 10 lines, 20 lines, even 100 lines. The field is negligible. The compass needle will hardly deflect. So therefore B4, B5 should be 0. Very good questions can be asked you. The interaction between solenoids when you are discussing, no, I think this you have to take care. Okay, fine. So this is about, now come for this one. So what is the field strength at 4, 3 for the path will be 0. For the 1, 2, it will be non-zero. So let's assume that path length equal to L. So what is the magnitude of magnetic field strength inside the solenoid? We know it is B. That has to be determined. So I'm going to integrate 1 to 2 B bar dot dl, 2 to 3 B bar dot dl, 3 to 4 B bar dot dl, 4 to 1 B bar dot dl is equal to mu naught. What is the net current enclosed by it? Two rings, two turns you are seeing, no? You are seeing this some two turns. So and what we have is number of turns per unit length. No? There's a formula. Some n turns will be enclosed here in a length L. This is some I'll write it where L is the length of solenoid. Capital L will take it. Yeah. How you define small n? Number of turns per unit length. So in a length small l, how many turns should be there? Shall I multiply like I want number of turns in a length capital L, n number of turns are there. In a length small l, how many turns are there? Shall we write small n only? So the ratio must be constant, no? So n dash by L. So n dash by L should be equal to nl. So n dash equal to n small l by capital L. We'll agree this. So number of turns enclosed by the plane curve. So into I. Let I be the current. I'm showing that I here. So this is the net current enclosed. Will I agree? What is n dash? Number of turns. Number of turns encircled in loop. Let's come for this one. What is value of B bar dot dl? Oh, B bar is in the direction. I'll change symbol. 2, 3, 4. So dl is here. This one. There's a dl. Here there's a dl. The black color strip is what? I'm showing that as dl. Look at now. What should be everywhere B bar is parallel as you move along the path 1, 2. B bar is parallel to this. So what should be the value of that? B into L. This should be 0. Any reason for that? B bar is perpendicular to DL at 2, 3. B bar like this, DL like this. So angle between them 90 degree. Or you can write equation. So there should be B let me write B dl cos 90. B itself is 0 dl. Don't write any other thing. So B itself will be 0 there. B dl cos 90. This will be 4 to 1. This should be equal to mu naught. What is n dash? You can write it as n small l by capital L into this is I. What should be the LHS? This one integral 1 to 2 dl. This will be 0. This is 0. Then this will be 0 equal to mu naught n L by capital L I. What should be the integral of 1 to 2? Should be BL. So finally, how much it is equal to mu naught n capital L by L. And what is capital N by L? Mu naught Ni. So there's a field due to solenoid. I think we have derived it, no? This is what are the assumptions we are making? It's a long solenoid. Where the field is uniform, there we are find out. Where the field is non-uniform, we cannot find out. Finish out. Don't bother anything big. Strictly, we are discussing for long solenoid. So for short solenoid, we can't find out. Leave it. So come out of Ampere's circuit law. Already you have formula. Use that formula. Don't fight with anything here. No. So now look at this one. So instead of this square loop, I'll assume some other circular loop. Enjoy mathematics. That's all. No? You have to enjoy mathematics. Nothing is there. So therefore, what is all Ampere circuit law? Ampere circuit law is all about choosing suitable plane curve. Now we'll go for inside the long wire. So as we know, this is a long wire, long current carrying wire.